mechanics review. So here we have our speaker introduction. Dr. Lissimeng Lee will be taking care of the fluid mechanics review. He's an associate professor of civil engineering. Dr. Lee is dedicated to advancing environmental sustainability, resilient infrastructure, and equitable engineering education. He teaches courses such as fluid mechanics, environmental engineering, water resources, and environmental remediation here at CPP. If you could, please give a round of virtual applause for Dr. Lee, and I will turn it over to him to get started with the session. All right. Dr. Lee, you should be able to share your screen whenever you get a chance.
All right, good afternoon, everyone. Thank you very much for the virtual applause and latest review session that we have planned for fluid mechanics. And I've been thinking about this. Fluid mechanics is a big class that I'm teaching for the whole semester. How can we spend a few hours, even I give you this 5 hours review session, we won't be able to cover fluid mechanics completely. It is just mission impossible for any instructors to do so. And if we do that, you are not able to really digest everything that we try to stack into a few hours. So instead of giving you a long review sessions, giving you all the things that you need to know about fluid mechanics or highlight things that you need to search for, I think about a different way. I think about how we can plan for this examination, how we can plan to pass this examination, how we can get some effective tips to do so. Okay, every exam has a purpose. FE exam has its own purpose. So my goal here today, besides talking briefly about fluid mechanics or hydraulics in general, I'm going to give you more effective tips that you can apply to all the subject topics and practice on your own. This is why it's a very short session, about 1 hour, less than 1 hour. But I trust you are going to get more than hours of lecturing from this 1 hour. All right, so let's talk a little bit about my background. All right, as Lynette mentioned, I'm teaching at Cal Poly Pomona. Classes I teach include fluid mechanics, water resources, environmental classes. Those are my classes of passion. And I'm a licensed civil engineer in the state of California. So many of you, this is your first step going towards the PE. EIT is just get you the entry ticket. Okay, there's a long way to go, but let's get this one nailed down on your first try. This is quite important for everyone to get your FE as soon as possible. As I mentioned, that is the entry ticket. Let's talk about what this exam's about. Let's share some effective strategies. And at the end, let's do a few practice about fluid mechanics using part of the strategies I'm going to share with you. All right. Every exam has a purpose, as mentioned. So what does this exam want us to do? This is quite important to understand the purpose of FE. It is a big examination of 5 hours plus. Okay, I believe you never take an exam of this long in your life. And here, FE, this is the first one. And PE is going to be 8 hours examination. So you're going to see that number of time, the amount of time, the number of questions are overwhelming. You're going to start with a non-disclosure agreement. You have to say yes, otherwise you finish your exam in 2 minutes. So do that. And tutorial is to get you familiar with the interface of the exam portal, so you can practice a little bit before jumping into the actual questions. Speaking of the FE exam questions, you can see from the NCEES website, there are 110 questions stacked into 5 hours and 20 minutes, and that is 330 minutes. So approximately a little less than 3 minutes for every question on average. You can take a 25 minutes break in between. So what do you think? 3 minutes for each problem. What does the exam want you to do? It does not want you to do engineering design. It's not going to ask you to do detailed, complex questions overall. Something that you can manage. 3 minutes, that's enough. Okay, so what I define FE is to find your equation, is to finish the estimation, finding equation is easy to understand. You need to know the equation. You need to find the right equation to the right job. Okay, we're going to talk about how to find the equation very soon. And finish estimation. Okay, I use estimation rather than calculations because you are looking at most nearly. They like to use this phrase, most nearly. So it is about approximation. You may get a number from your calculation, 103, and one of the options 105. Choose the 105, right? Because that's the closest to what you have found. All right, what do you need during this exam? It's an open book exam, in fact, but open book only to limited resources. That's your FE reference handbook. If you have not reviewed FE reference handbook, do so by search this in a Google search, type keyword FE reference handbook. You'll be able to download one version for free. Another thing you're going to search for is exam specification. That's going to be a list of topics you will be tested for this examination. So make sure that you download the two documents and they are free. Once you have these documents, you have a guideline about what to do, about every topic you review for. Anything that is outside the scope is not going to be tested. So don't worry about things that's not listed in exam specification, and do not worry about equations that you do not see in FE reference handbook, because this exam is the open book. It does not want you to remember equation. Our goal is to find the equation. If you don't find the equation, you don't have that concern. All right. So make sure that we understand what this exam is about. Then let's take this exam strategically. Okay, this exam is not a comprehensive exam for you to showcase your talents of this subject topic. It is simply a practice of equations and estimation. So do things 100 times without knowing the purpose is wasting your time. Do things 100 times with purpose, you are going to become an expert on it. And we are doing the practice of FE exam on purpose. So you will become an expert of FE exam at the end of your 100 practice. Okay, so let's talk about exam strategies. What do you need to do to make yourself a self-made expert for FE exam? Let's start with unit conversion. Unit conversion is probably the most important thing you need to know about this examination. Besides testing all the equations, you are doing estimation. So a lot of times you're converting cubic feet into cubic yard, gallons into cubic feet, gallons per day into cubic feet per second. Those are unit conversions you do repeatedly throughout this exam. You can be surprised how many times you go back to the same page to find those unit conversion factors. And these unit conversion factors, they are available in the handbook, but you need to find that page instantly. So I'm going to share with you one magical keyword that will take you to the unit conversion page in the handbook in 1 second, no more than 3 seconds. And this is what you need: speed and familiarity. All right. And that keyword, after attending today's session, if you never heard about this before, you are going to remember it forever. Is anyone here driving a Tesla? And if you don't, do you want to drive a Tesla? So the keyword to get you to the page of unit conversion is Tesla. Okay, just like the car Tesla, just like the company Tesla. Whether you like Elon Musk or not, that's the keyword to take you to unit conversion. Every time you type this, you are on the page of unit conversion. In the FE handbook, there are 3 places you see Tesla being mentioned. In the PE exam, when you take your PE, Tesla becomes more important because there is only one place that you can find Tesla as a keyword. And for PE exam, Tesla is only shown in the unit conversion page. So remember this keyword. I don't think it takes efforts to do so. Okay, so That's my first tip for all of you taking this examination, whatever subject you're working on, unit conversion. Number two, let's talk about solving problems. There are problems that will be very straightforward, one sentence question. You know right away what the question is asking. There are also questions that's going to give you a very long statement, extremely long. If not, they give you additional information that you do not need to use during this exam. So you are going to really look at something important first. So where do we start? I took this phrase from one very classic reading. It's called Seven Principles of Highly Effective People. We can convert that into seven principles for highly effective examies. One of that principle is from the end to the beginning. So let's talk about how do you use that principle. Here I'm going to give you one water resources example. This is not going to happen in your FE. This is too long. Probably in the PE exam, you may have a long statement like this. It is scary. It's very intimidating to start working on problems like this, right? Your instinct is, where do I start? There's so much information. So from the end to the beginning, help you to solve problems like this. When there are a lot of information, too much that you cannot handle at first sight, you start from the end. From the end, we find keywords that defines this problem. We find keywords that take us to find the right equations. Okay, remember this FE exam is to find the equation, finish estimation. So determine the flow rate conveyed by the channel under conditions described above. That is the last sentence. So flow rate, that's one of the keywords. Channel, that is another keyword. A flow rate in the channel. Channel is open channel. So you know you're going to look for hydraulics problem. You're going to look for flow rate. So you can type the keyword channel in the search bar. You'll be able to find open channel hydraulics. You may search for flow rate in that section. That's going to take you to Manning's equation. If you're more familiar with open channel hydraulics, you know Manning's equation, which is actually mentioned in the statement. If you look further, there's open channel, there is steady uniform flow conditions. There's also that word Manning's roughness coefficient. Those are all signs that you should look for Manning's equation. So you type the keyword. If you're very familiar with these open channel hydraulics topics, you find the keywords Manning's equation or just Manning's. You'll be able to see this equation in the handbook. And this equation is going to be really helpful for this problem. Now, we went from the end. Now we find the equation. We're going to analyze how to solve this problem, right? In order to find the flow rate, you need to know N, which is Manning's coefficient. You need to know A, the cross-section area of the channel. You need to know R sub H, which is hydraulic radius. And you need to know S, which is the slope of energy. We're going to look at the handbook closely and look at the explanation for each of these symbols. Especially you need to pay attention to the units. Many of these equations, they have specific units that you need to follow. Okay, unit conversion, again, is a must. I'm going to give you a quick test. What is the keyword I share with you for unit conversion? Type that in the chat.
Tesla.
Thank you, everyone. Thank you. You're doing really well. So Tesla is that keyword. So we type Tesla to make sure all the units are taken care of. Now we're going to look at the statement slowly, a second time from the beginning of this, and we're going to find out the information we need. So we're going to look for N, Manning's coefficient. We have that circle out, 0.013. That's Manning's coefficient. Okay, we're going to look for slope of the energy grade line S, and that is 0.0015 feet per feet. So far units is great. Let's go on to look for other information. We need A, the cross-section area. We don't have it. Okay, we need R sub H, hydraulic radius, defined as cross-section area divided by vatted per meter. We do not have that. But we are going to find it out because we are provided with information related to the channel. If you look at the question, that there is this saying that let me give a highlighter to highlight where we're looking for. So you can see that right here. The energy grid line is assumed to be parallel. The channel has the bottom width of 2.5 and the side slope of 2 to 1. So this information gives us how this channel looks like. So you're going on your scratch paper, you're going to draw this channel cross section, because by looking at this cross section, you will be able to know the cross section area A. So it's a trapezoidal cross section. We can calculate the cross section area using the bottom length and the top length divided by 2, then multiplied by the height. We are given the height, and we know the ratio of the height and the width, V and H. So we can find exactly the cross-section area. So here I'm going to give you this answer 5.88. In the exam, you do these calculations on your own. We also need to know the wetted parameter. So wetted parameter is the length of the sides that have contact with water. And water is going to one side and the two side and the bottom. So we're going to add the two sides and the bottom together. That's the full length called wetted parameter. So now we can find A and P. We can calculate hydraulic radius, which is A over P. We have hydraulic radius equals to 0.75. And now you can see that we found everything. Let's make sure that we double check if we have everything that we need for Manning's equation. N, we got it. Okay, S, we got it. A, we have it now. And R sub H, we have it now. Okay, we can put all these numbers into the Manning's equation right away. We found this flow rate is 21.5 cubic feet per second, most nearly. Estimation, okay? One of the options you're going to see would be either 21.5, or they may convert that into another unit, maybe gallons per day. So unit conversion, you're going to use that again. You see that unit conversion is being tested also again and again, even in the same question. But now, as we went through this process with this example problem, using from the end to the beginning method, I think it's not that scary, right? You can see this is a long statement intimidating. We have a way to solve exam problems. This is just an exam. It is just an exam problem. But surprisingly, this method also works really well in real-world engineering practice. If you start from the question, define that question clearly, you can go backwards to find out solutions. So that is one key skill that we learned from FE and PE exam. This is an exam essentially, but it teaches us some very useful way of thinking in engineering practice. So it's not wasting your time when you practice this method. It makes you into a better examiner. It makes you into a better civil engineer in general. So keep practicing this. You can do that for every topics in the exam. You are going to take your final exam very soon. If you're in the school, you're going to have your final examination maybe in one month. Try this in your final exam, especially for problems that is very long. Be familiar with equations, find the equation from the end, then start from the beginning to find the estimation, to finish the estimation. Okay, I hope this tip helps. This is not fluid mechanics, so if you're looking for fluid mechanics today, I'm going to disappoint you with this example. But if you're looking for more effective strategies overall for this FE exam, I believe this is going to be more helpful than going over 10 fluid mechanics problems on different topics. Now let's go to the next tip, next strategy. How do you solve for non-quantitative problems? This exam, 110 questions, you're probably able to find 20 questions that are non-quantitative. Those questions can be, what is the chemical formula of ozone? Okay, if you know chemistry, if you know environmental engineering really well, you know ozone is O3, that's a 1 second option, right? 1 second to solve the problem. But if you don't know at all, you're simply just going to guess. So terrible thing, right? You either know or you do not know. You either earn that 1 point with ease, or you lose that point, or you risk that option because you have no idea. Now, let's think about how we can solve these problems, maximize our points for non-quantitative problems. Those are memories. Human cognitive studies shows that your brain is not able to maintain the memories forever. Nobody does. Your memories start to decrease one day after you read the message. Okay, so you're working on some readings, you're working on one problem, and you say, hey, I remembered it. I'm going to leave this until I take the real exam. No, don't do that. When you work on readings, when you work on non-quantitative problems, whenever you think you are not going to remember it, make a note. I suggest everyone, as you prepare for your FE exam, prepare a note. The note will be used just for non-quantitative problems. So you are going to put a note on the side. It could be a digital note as well, as long as you are aware of where to find those information. This is a note to keep track of all the information you probably won't remember during the real exam. So you're going to leave that note alone until 1 week away from your FE exam. If your exam is scheduled next Monday, the Monday after next Monday, okay, you are going to start reading your notes now. You're going to start reading the first time 7 days before you're going to read the first time, knowing that the next day you're going to forget 50% of what you read. Okay, so at the day 6, you're going to read that another time. So that way you have reinforced your memory, but you're going to begin forgetting all those questions, all those informations again. All right, I'm going to draw how your memory will look like over time. So day 1, you remembered, but day 2, you almost forget everything, half of that. So you reinforce this memory by reading again. You're going to start forgetting things again. Okay, maybe give yourself 2 days break, and because your forgetting rate is going to decrease. So day 5 before your exam, or day 4, you're going to read again to bring up this memory to its maximum. Now, day 1 before your examination, you do that again. Right? In one day, on your exam day, you're most likely able to retain 90% of the memory. That's much better than 50% of the memory. I know everyone's memory is slightly different. You may forget things faster, but if you do this way, repeating with intention, you will be able to retain a significantly higher percentage of your memory for concept questions during the exam day. And after you take the exam, feel free to throw the notes or send it to someone who is in need. You don't need to remember those things anymore, hopefully. Until you take your PE exam, you're probably going to pick up some of the concept questions, but PE exam focuses on very different things. So most likely you won't see the same things. All right. That's how we do non-quantitative problems. It is just during that 1 week window. It's going to be more effective than long term, but you need to have your note ready. Now let's talk about the situation where you are taking the examination and you really don't know how to solve a problem, or you don't know the concept at all. You have no idea which answer is right. During the exam, there is one option that is called skip option. It is also another function called flag. Okay, my strategy here is called safe skip. So safe stands for scan, assess, flag, and enter. You start scanning the problem. Within a few seconds, you have an idea you will have an idea about the difficulty level of this problem. You will know if you are able to solve the problem with ease, or you are going to spend time and not able to solve the problem at all. You will have that idea right away. Don't waste more time after you scan and assess. The next step after assess, and you know you are not able to solve this problem, you are going to flag this problem. Flag means when you finish all the problems, you can come back just to the flagged problem and give a second try if you have time. Okay, but before you skip to the next problem, the last step is to enter a guess. You probably prefer A, just guess it's A. Doesn't matter. You probably prefer number 9. Just guess a number that has number 9 in it. It doesn't matter what you guess, but you need to have a guess. Because guessing it, your chance of getting the right answer is 25% for 4 options. But if you do not guess it, the chance is 0%. So you tell me if you want 25% or 0%. It's up to you. I believe every rational person is going to choose 25%, even though the chance is not that high. You got a chance. Okay, speaking of guessing, I'm going to share with you a real example in my class. I teach fluid mechanics on a regular basis, as you know. And one semester, I put all the examination into the FE style. So that means you have multiple choices, mostly. In that exam, all the questions are multiple choices, 20 questions in total, and you have about 3 to 5 minutes for each question. And at the end of the class, when the students submit their exam papers, one student come to me with his paper, and I saw the name is there, great. But then I turned the page a few times. I said, no, you only answered one question out of the 20 questions, and they are all multiple choices. Why don't you use this 1 minute? We still have 1 minute. Why don't you use this 1 minute to make a guess? So he took my advice and he went back with his exam paper, which is almost empty. So he started guessing 19 guesses in 1 minute. So he finished all the 20 problems in 1 minute, technically 1 minute. And then I took this exam paper back home to grade, and then I look at his exam paper because I'm very interested about his result. Problem number 1, right. Problem number 2, right. Problem number 3, right. Problem number 4, right. I was so surprised. It's like he had superpower to see which question is right. And when I finished grading his exam paper, 20 questions, he got 15 out of 20. That is 75%. So he got 75% for that exam. That could be you taking this FE exam. You guess, you skip. Okay, you guess before skipping. Okay, I haven't finished that story. The worst part of that story from instructor point of view is that the only problem that he tried out of the 20 problems was wrong. So he basically guessed to get a passing score, better than passing score. Okay, so if you have 70%, 75% for FE exam, you definitely passed it. So don't hesitate to guess for difficult problems or problems that you simply don't know the answer. Okay, so safe, skip, safe, skip. Okay, the most important is to be safe. Because if you don't, you run out of time and you may end up not having the chance to enter your answer. All right, now next. So this is one of the online interface similar to the real exam. The flag for review function oftentimes is on the top. So during your exam, you have these 2 windows. On the left side of the window, you are going to have the PE handbook, FE handbook. So you can find those equations by using the search bar. On the right side of the window, it is the questions. So you can look at the equations and the questions side by side. This is exactly the interface you see. Not exactly, because this is not from the real exam, but this is something that you will see. Right. So next one, the next and the last tip I'm going to share with you today is called a 10 out of 10 rule, 10-10 rules. We all want to get 10-10, but taking the examination, we do not want to be perfect. Your goal is not to be a perfectionist for this examination. Your goal is to pass the exam. So the whole thing that you do during this preparation process is to just practice on purpose. And you practice on purpose for the exam strategies. For example, the from the end to the beginning method. For example, the safe skip method. Okay, so practice this consistently. And every time you practice, you need to have at least 10 problems for every practice. At least 10 problems is the minimum, because if you only practice one problem or two problems at one time, you will not likely to have the chance to skip problems that you do not know. So you won't experience those stress. You won't experience that feeling that I'm skipping a problem and I feel guilty skipping it. You know, a lot of people have that feeling, I need to be a perfectionist. It's totally understandable, but you need to forget about perfectionism during this exam. You need to start thinking about how I can get the most. So do 10 problems at one time for every practice. For every practice problem, you are going to set a time of 3 minutes. So 10 problems will only be 30 minutes of practice. It's not too bad, right? 30 minutes, you can take the 30 minutes every day on a daily basis. If you have more time during the weekend, you can try 20 problems. That's going to be just 1 hour. But by doing this, you are able to know how it feels when you skip a problem, how it feels when you guess, and how it feels to practice different types of problems at one time. Okay, so do that consistently throughout your preparation process. And the next 10 will be at least 10 practices before your final exam. Okay, if you can, try 50 problems for that's going to be about 2.5 hours for that. Okay, that's the situation when you have a long preparation window. If you have half a year for this preparation, great. You can definitely plan for 10 practices with 50 problems along the way. Okay, if you really don't have the time, your exam is scheduled next week or next month. Okay, hopefully it's next month. If your exam is scheduled for next month, you're going to do the practice maybe more intensively. Maybe do not expect for 10 practices, but rather you can say, I'm spending 1 weekend to practice 100 problems. Okay, it's going to be longer, but it's going to be a more real exam scenarios that you can practice and feel how it feels to test your exam stamina. All right, that's all the strategies I'm going to share with you today. But if you need more strategies, I have a YouTube channel that I created for my class because I'm teaching fluid mechanics. I'm so fed up answering the same questions for the same problems. Okay, so that was the motivation when I started this channel, and it looks like it's working well with students who are taking my classes, fluid mechanics and water resources. And another information I would like to share with you, if you haven't taken those classes yet, I'm offering it this summer. This class is C2061 Fluid Mechanics and Environmental Engineering and Environmental Engineering Lab and Water Resources Engineering. Those are topics you are going to see in your FE exam and PE exam. And my goal for these classes is to prepare students for the FE and PE. So both levels will be included, and it's not going to be a traditional style of class. We're going to make this into a high flex mode. High flex mode means maximum flexibility. You can take the class in person. You can take the class online, live, like what we're doing right now. You can also take the class by watching the videos at your time. So maximize the flexibility. Currently, I think fluid mechanics is going to be full very soon. And environmental engineering, we have seats. Water resources engineering, I have opened one section, it's taken instantly. So that section is full, but department was very supportive for our students, and they allowed me to create another class of 30 to 11 water resources engineering, and that class is available. The second section of water resources engineering is available. And like I said, I'm not able to share everything about fluid mechanics with you. Even you give me 10 hours today, I won't be, just simply not. And I won't be able to tell you everything about water resources engineering for FE and the P exam. But with one class that is 10 weeks long, we can look at those topics in details. We can look at those topics and practice with intention. That is what we need. Okay, so I will leave those options for people who are interested. Even you just want to sit in for audition, that's okay for me if we have seats available. Okay, I'm going to prioritize students who are registered. Classroom size is limited, so yeah. So just let you know this information that you can take advantage of this summer. It's a 10 weeks. I would say that's called an exam prep course, which typically costs a few $1,000s if you go for something like commercial places. But CPP has always been that reputation of practitioner friendly and practice oriented. So my focus for these classes will be focusing on engineering exams. All right, let's talk about hydraulics a little bit before we finish today's session. I see that we have 20 minutes left. So let's look at some most important things about hydraulics. And when I say hydraulics, that includes open channel hydraulics and closed conduit hydraulics. In most of the engineering exams, when they say water resources, they are referring to open channel hydraulics. When they refer to closed conduit hydraulics, they are talking about fluid mechanics to some degrees. Okay, but I want to share with you the universally most important equations for hydraulics. The first one equation is called continuity equation. And by the way, I'm taking these images from PE handbook. PE handbook is different from FE handbook. So if you are looking at a FE handbook, those section titles are different. Okay, but you can still find continuity equation and energy equation in the FE handbook. The first equation you need to keep in mind is continuity equation, which is flow rate equals to cross-section area multiplied by the velocity of the flow. This is very important equation and very helpful, very effective. Now, second equation you need to know very well is called energy equation. This equation shows the energy gains and the losses at the inlet section and outlet section. So if you're looking at the water going in one direction, we have an inlet section, section 1. We're going to have another section, outlet section, section 2. The water has energy. The energy carried by water stays in 3 forms, which will be pressure head, elevation head, and the velocity head. This energy is always expressed in the sum of the 3 heads in energy equation. Okay, so the first thing you see here is the energy at section 1. Now water goes towards section 2. At section 2, the water also carries the 3 forms of energy. That will be pressure head, elevation head, and the velocity head. Now at section 2, this is the energy we have left. So the energy at section 2 can be higher if we have a pump that's add energy to the flow. But if we do not have a pump, the energy is going to reduce along the way because head loss, which is this HF in the equation. In fact, this is not rigorous. Okay, don't think that the handbook is going to give you perfect equations. Most of the time, the handbook is giving you equations that are misleading to some degrees. So that's why you need to be familiar with the handbook as your number 1 priority rather than solving problems. Okay, handbook is very, very, very important, but do not rely on all the information listed there. So you need to know what is listed there, how you can use these equations while you practice the different topics. Okay, so HF, typically that's called friction head loss. That is the head loss due to the friction effect along the way. It does not include the the component head loss, which is caused by components along the way, such as valves, such as a T or an elbow or bend. No, those are not in this equation. But it should know head loss is major head loss, which is friction head loss, plus minor head loss, which is component head loss. So those are basic concepts. We will go in details as we take engineering classes. If you follow fluid mechanics the whole semester, you will understand what I'm talking about. But if you rely on 1 hour of lecturing today, you probably don't know what I'm saying. Okay, so the same as this HM, it can be pump, it can be turbine, and it can be related to energy. It's just mission impossible for me to tell you everything in 1 hour or 2 hours or even 3 hours. Okay, so let's make sure we mark these two equations in our handbook for these topics. And let's look at examples. Okay, let's look at problem number 1. We are going to practice the method I teach you, okay, from the end to the beginning. Velocity of the discharge jet is mostly questions about velocity. And it is a discharge jet. So discharge is Q, velocity is V. Velocity times cross-section area. If we want to know the velocity, we need to know discharge. We need to know cross-section area. All right, now we're going to go for this. We're going to go for this information. Do we know the discharge? Let's look around in this statement. We have not this information. Okay. Another thing continuity equation tells us is V1 A1 at one section. This product of these two at one section equals to the products at a different section. If you go back to the equation, A1, V1, A2, V2. All right, so now let's look at this again. We do know that at one section, which a diameter of 2 feet, the velocity is 4 feet per second. And at another section with 4-inch nozzle, what is going to be the velocity? You see that there's some additional information not used at all. 2 feet, that's not useful. Okay, so we know that we need to know velocity V2 because that's the velocity at the nozzle. Rearranging this continuity equation, I believe you can find the answer really fast. It is not a complicated problem, but if you don't know how to go from the end to the beginning to find the right equation, you're probably going to spend longer time doing this type of questions. You're probably going to start looking at head loss. Okay, that's just a distraction rather than looking for the solution. So that's my first example for solving the problem. You can find the answer is 180. It's not a difficult problem, very typical FE style. But it's also give you distractions. Now let's look at something more fun. If you're doing taking your FE exam and you're looking at a question like this, it will be multiple choices, by the way. So worst case scenarios, you'll be able to guess one option. Okay, you probably can guess it right. Now let's look at this problem. We're going to start from the end to the beginning. You're going to save a lot of time by doing this. Okay, calculate the total head loss in the system. Head loss is the keyword. You can type the keyword head loss in your FE handbook, and let's see what we land. You'll be able to find the head loss chapter, and you're going to find head loss is a sum of major head loss H sub F and minor head loss H sub M. That's my preferred symbols. The handbook may give you different symbols, but the idea is you need to calculate major head loss and you need to calculate minor head loss. Then let's talk about major and minor head loss. Do we have the information to calculate major head loss? You're going to look for equations related to major head loss, H sub F. Very soon, you'll be able to find the two equations. One equation is Darcy-Weisbach equation. So I'm going to put the Darcy-Weisbach equation. Another equation is called Hazen-Williams equation. These two equations both are in the handbook, and they can be used to solve for major head loss. However, you are going to choose one of them according to what is being provided in the statement. When you see roughness epsilon with a unit of millimeters or inches, this is a sign that you are going to use Darcy-Weisbach equation instead of Hazen-Williams equation. If you're using Hazen-Williams equation, you're looking for the Hazen-Williams coefficient, which is C equals to a number that is typically larger than 100. So again, I'm not able to tell you what roughness is, what is Hazen-Williams coefficient with this review session, but fluid mechanics class will teach you all of this in details. And you will understand exactly what we are doing here. If you already take fluid mechanics, I hope this talking clicks to you, okay? If not, well, I do think you need to do some additional review for fluid mechanics, even you finish that class. All right, so let's talk about the minor head loss now. Since we know how to solve a major head loss, and once you have the Darcy-Weisbach equation, you're going looking for parameters related, which will include the length of the pipe, the diameter of the pipe, the roughness, and the Reynolds number for friction factor and velocity head. Those are things you need to know. Minor head loss, you will need to know minor loss coefficient. You will need to know velocity head. So we also know how to solve for minor head loss. So minor head loss has a very simple equation. That equation is the K value, which is the minor loss coefficient times velocity head. That is for every component. Every component, you do this. So this is quite important to know the equations first, and now you can go backwards to find what's missing to complete that solution process. Now I'm going to show you the solution process. This is a standard solution from step 1 to step 5. But in fact, what we did is we start from the end. By looking at the total head loss, we know we are going to use this equation for total head loss. And then we went from this equation to know we need to calculate minor head loss, which is in the equation. And we also learned from this equation knowing that we need to find a major head loss. So now we're going to look for the equations to calculate minor head loss and the major head loss. We identify Darcy-Weisbach equation and the equation for minor head loss. Now we're going to go backwards because you know to find major head loss, you need friction factor. And to know friction factor, we need the Reynolds number. We need relative pipe roughness. And we got this done, which will pave the way for major head loss. And we also need to know velocity for velocity head. And to find velocity, we need to know areal. So that's why we had areal before velocity. Okay. So when you solve this problem, you went from the end towards the beginning. And then when you really do the estimation, find the estimation, you did from the beginning to the end. That is the idea of from the end to the beginning method. Okay, so keep practicing this method, especially for difficult problems or looking at seemingly difficult problems like this one. And that's going to be very important for this examination and for all your engineering examinations in the university. All right, let's use the last few minutes. Let me show you how this exam looks like. So if you're looking for information, you're not looking further and everywhere. Make sure that if you have your exam scheduled, arrive there 30 minutes before the exam. Make sure this is quite important to be early because you're going to check in. They will check your documents. They're going to check your ID. They're going to make you input a palm van. So the palm van machine is like 5 fingers splits out, and they're going to take the palm van. So every time you go into the testing room, every time you go out from the testing room, they are going to take your palm van. So when you check in, it takes time. It does take time for you to check in. So make sure you arrive early. So you're not panicking, you're not running late for your exam, which would be least ideal situation, right? You have your exam, everything ready, but you're late. And if possible, arrive at the center one day before so you can check the traffic, you know how long it takes during that hour, and you can find nearby parkings. You can, on the exam day, you arrive early to finish the check-in. And for your examination, you will be able to use NCES approved calculators without the covers when you practice for this FE examination. Never practice with your calculator with cover. So this is a typical calculator that you use for exam. Remove the cover, separate them, and throw the cover away when you practice. I know it sounds dumb, but don't keep it in your hand, because when some people like to put the cover just right on the back. No, that's feeling of having a cover. It make the calculator heavier, and the feeling on your hands, it's different. You want everything about familiarity. You want familiarize with the setting. So practice without a cover using NCES approved calculator. I also highly recommend everyone to take two calculators rather than one, just in case your calculator dies. You still have a backup. And make sure that your two calculators are tuned to the same mode, to the same setting, everything identical. I made a mistake when I took my PE exam. So I skipped FE because I had a PhD, so I could waive my FE requirement. So I took the PE exam. That's my first engineering license exam, and I had two calculators. Great, but I have one calculator that I practice on just in journal. Another calculator, I always think that's a backup. However, when I open the other calculator during the exam day, because the two calculators look the same, so I didn't know which one was the one that I practice on regular basis. And I took the calculator that I actually didn't use. So when I sit in the exam, I say, oh no, this is not the same mode. I like to see decimals, but what I'm seeing in the calculation result is scientific notation. Terrible. So I tried to bear with that, but I couldn't. It was so disturbing. So I decided to raise my hand, get out from the testing room, and go to my locker and took the right calculator, go back. And before I can go back, they will check my everything. They will check my palm vein. So in total, I wasted about 5 minutes for that PE exam. And you never want to waste time during your exam, especially for silly mistakes like this. So tune two calculators to the same mode. Okay, worst case scenario, if you're extremely unlucky, you're going to have two calculators not functioning. There is still a way to use calculators. On the screen where you take the exam, there is a calculator function that you can use. But obviously that's the least ideal option, because you have to type all the numbers. It's not the same environment that you practice. Okay, speaking of practice, you also want to make sure you practice with the right thing. So you can practice with reusable booklets. That's what you're going to be provided with, and a marker. If you have the finance to do so, have three markers at least, and have buy a reusable booklet for your practice. It's not written on paper. It's not written with a pencil. So every details make you become more familiar with the exam environment, with the exam condition. So that helps you to get higher performance. This is some details that you don't think about when you prepare for this FE if no one told you to do so. So that's why I think about sharing this with you as you are in the process of preparing for this exam. And you are allowed to take the locker key. You're allowed to take your eyeglasses without a case. And by the way, they're going to check your glass. And so that may take additional half a minute. And you can, and I should take a light sweater or jacket when you're going to go to the testing room, because the room can have very low AC, especially if you're taking that at some centers, at some special states. If you ever need to take the exam in Florida, just for example, all the indoor spaces in Florida is like a fridge. So you can really feel frozen and have stomachache and have diarrhea. when you take the exam, that's the last thing you want to know to happen. Okay. So make sure that you have these things prepared as you go to take the examination. Now let's talk about just a few more items. This is the how the environment looks like when you take the exam. You have a very small sectioned table, just a very small space that you can work on. You have that scratch paper with the reusable booklets that's been provided to you. Every time you can have two booklets. If you use up the booklets, raise your hand. People who work there is going to come to you and give you new ones, but at the same time, they're going to take away the old ones. So think about it. You probably want to use double both sides of the booklet when you work on the exam. All right, and let me see what else I have here. Okay, so it's a summary of everything we have covered about what to do for your exam date. If you need more information, look for YouTube. There are channels created by NCES. They have made these videos to tell you in detail what to expect during this FE or PE exam days for computer-based exam. Okay, very important as you start. When you read this non-disclosure agreement, always click yes, or you finish your exam in 2 minutes without doing anything and you fail. Okay, so besides the multiple choices problems, you may also expect some questions having different formats. This is when the tutorial session for 8 minutes, you can get yourself familiar with how to use the different functions. This is the draw line, straight line function. And there are different type of questions you may expect. Multiple correct answer question. And this is typical multiple correct answer questions. You're going to choose multiple choices rather than one. Okay. You are also able to see questions that relies on point and click. So you're going to click one side in the figure, for example, here. And some questions will be drag and drop. So you're going to drag the name of the sequence in this water treatment process to the right location. You need to make sure all the sequence is correct to earn that 1 point. And my least favorite type of question is the fill in the blank, because it is like multiple choices. However, you do not have the options to guess. So it's more difficult to guess the right answer with fill in the blank. Good news, this is not very common in the FE and PE exam. You're probably going to see one, no more than two questions of this type of the fill in the blank. All right, and that's the end of my sharing with you for today's review session. We are perfectly on time. But if you have any questions about FE, about PE, or if you are interested in taking classes with me this summer, definitely feel free to reach out to me. My contact email is sli@cpp.edu. Or you can search my name on the CPP website. So you'll be able to find my profile and know how to reach out to me. All right. Thanks everyone for attending, and I wish you best of luck for this exam preparation. Pass on your first try.
Thank you very much for your time, Dr. Lee. We really appreciate it. This was very informative, was very wonderful. Thank you for doing this. And yeah, thank you everyone for attending. If you haven't filled out the sign-in sheet, please do that. I would really appreciate it. Thank you for attending, and thank you very much. Have a good rest of your Saturday.
Thank you, Lynette,
All right,
and wish everyone a happy weekend.
thank you very much, Dr. Lee. Have a good weekend. See you.
See you.